Yep, camps on everyone. Let's start off. The last thing we did was this infinite honeycomb. Great, let's go ahead. There, all capacitors are C. Find CAB. So this is another type of symmetries, we'll see. But first give it a minute, try, and then I'll show you. Now listen to this thing. So these kind of circuits, right? There's a different type of symmetry. So let's see the theoretical part. So the first thing, right, I like to call this thing as perpendicular bisector symmetry. Again, I just named it. So in this kind of symmetry, how will the circuit look like? If A and B are terminals of the battery, that central line will be the symmetrical line. So the A and B will be the mirror images. So the each side is a mirror image. Right, and the terminals A and B are on either side. So what happens with this line? First thing, since it is a symmetrical line in the middle, the line is equipotential, isn't it? Every point would be a midpoint on the circuit. So the bisector would be an equipotential surface. And this is not the first time you're seeing this. We have already seen this last time. If you remember in the cube cup problem, AC, this was a symmetrical plane, isn't it? The plane was a mirror, left and right. If you see, this entire green plane will have same potential. So this entire bisector would be equipotential, right? That is, all nodes have same potential. So if you have any node on that line, they all have same potential. Therefore, any element that covered connected between them can be removed. Again, remember, every technique that you're learning here is exactly the same technique we're going to use in current. So any element between them can be removed. So if someone keeps a capacitor and like this, you can remove that capacitor. It is useless. That's the first thing it does. Second thing, it does something even better. The nodes along the symmetrical line, so nodes on the line can be opened up actually. Let me show an example. What do you mean by that? This would be the most important one. This will help you a lot. See, now look at our circuit that I gave you. So this is A and this is B. Now you can clearly see if you drop a line in the middle, the left and right are exactly identical. This is your bisector symmetry. That means whatever happens on the left, similar thing will happen on the right side. Meaning, look at this thing. If Q charge goes from A, Q charge comes out from B. Agreed? It will happen in the reverse. So if you say in this branch Q1 is going, can I say in this branch Q1 is coming down? Whatever charge goes out, the same charge will come out from here. If this is Q2, then this is also Q2. If this is Q3, then this is also Q3. It's all like a mirror image. What is happening from left to right, this will happen from right to left here. So now if you notice this, look at this point here. Something interesting is happening at this node. So that is a node on the symmetrical line. Did you see what happened there? If I remove that node, and now if I look at the chart distribution, this branch will be Q2, this branch is Q2, this is Q3, and this is Q3. So now you tell me, if that node is removed, does this affect the charge flow? So what was happening, you built a road like this. The traffic which is coming here is going this way. The traffic which is coming here is going straight. Whether the road is closed or open, it doesn't going to make a sense. It does not going to make a difference. So you can open all the nodes along this line. That's what I'm saying. So that node can be opened up along the symmetrical line. So now this is easy. Now it becomes series parallel once you remove this node. So basically this is the thing. So this node can be opened up. Since the chart distribution is not affected. Now if you try to solve this, this will become simple series parallel. This will be 5C by 6. Let me take one more example on this.
Sir.
Vihan.
So could you explain once again, like, what was the exact reasoning why we can just uh, assume everything is symmetric?
You're only saying, is it not symmetric?
But
Does the
sir,
circuit not look symmetrical, the left and right?
yes, sir. But why is it like
Then
only Q1 will go on that side and same Q1? Like, how does it know that?
because it is symmetric, whatever happens here, same thing should happen here. That is the whole meaning of symmetry. If I look at your face in the mirror, how do you know there is a ear on the right side? If I
Hmm.
close the left hand side, don't you know there will be an ear on the left hand side also? Symmetry, right?
Hmm.
That's why it is called symmetric, Ravihan.
Okay.
Your face is symmetric means what? If there is a left eye, there is also a right eye. If there is a left ear, there is also a right ear.
Hmm. Yes.
What do you think is the meaning of symmetry? You need to search in Google and let me know. Symmetry ka meaning why? Whatever happens on left happens on the right. Or else why do you want to call it symmetry? Don't call it. Let me show you one more. Listen to this thing. Let's say you have a circuit like this. Maybe this is looking too big. Let me just keep it simple. You didn't ask me in cube why it is symmetric. If they look identical, then they should do the same things, right? Look at
Yes.
this thing. This looks symmetrical. What do you think? So if I drop a line in the middle, do you all agree with this is a bisector symmetry? The left and right are mirror images. That means if you look at this node here, and this node here, they can be opened up. I didn't draw it properly, but see. So when I open the nodes now, the circuit will look like there. The circuit will become like this thing. See, this node can be opened up like this. Is that making sense? Now see, you have to be careful. Huh? You can open the node like this also, na? Don't open left and right. Open it along the line. What is the symmetrical line? This is the symmetrical line. And again, what is the reason? Whatever current flows in this branch will be the same in this branch. So this current is simply going, right? There is no need for it to, the branch is there, node is there or not there, that flow is not going to get affected. Is this clear, everyone? Bisector symmetry. So on that bisector line, whatever nodes are there, you can open them along the line. Clear with this? So this is a bisector symmetry. Then we have another symmetry called axial symmetry. So in axial symmetry, the two terminals A and B, the symmetrical line will pass through the A and B. Be careful, it doesn't mean it should be horizontal. You can have A and B like this, as long as the line passes through A and B, it's an axial symmetry. So previous one, A and B are on either side of the symmetrical line. So here what happens, the either side of the surface, so the up and the bottom are symmetrical, isn't it? That is the meaning of symmetry line. The either side of the line are identical. So here we can clearly see the either side are identical. So what you can do, you can just fold the circuit about that line. Ever seen a waffle? When they make a waffle, actually, if you see now, when they make it, so this left half is one waffle and the right side is one waffle. So they'll take this and they'll fold this over this, so you'll get one waffle. So if you see waffle is kind of like a symmetry thing, you overlap. And when you overlap, then they become parallel. Let me show you with an example. The same circuit, I just doubled it up. There. So this is A and this is B. You can clearly see This line is symmetrical, isn't it? So you can fold about this line. Why can we do that? Because look at this. Because up and down are same. This is C. This is also C. If you call this D, then this is also D. Because the up and bottom both are same. So when you fold it, you're just keeping C's together and keeping D's together. Now if you fold the circuit will become like this. Now that means this capacitor and this capacitor, when you fold them, if these two are in parallel, then what will happen? C and C will become 2C, isn't it? So wherever there were two capacitors, all these guys will simply double. So this and this will fold, this will overlap. So these capacitors will become 2C, this will become 2C, 2C. These capacitors will become 2C, whereas these capacitors, there is only one capacitor, you didn't fold them anything. So they will still remain C only. Is that making sense? So when you fold them, the capacitors in the middle, they don't have anything, just only one single capacitor. But every other capacitor will fold over itself and you'll get double capacitance. So all these red capacitors will fold, the green ones will remain same. In this, you can also see there's a bisector symmetry, then you can open the node and solve the circuit. So you can actually use both the symmetries back to back. There's nothing like if you use one symmetry, you can't use the other. Any doubts on these two symmetries? So bisector symmetry meaning A and B must be on either side of the symmetrical line. In this, what can you do? You can open the nodes along the line. Any element between on that line can be removed. Axial symmetry, the line will pass through A and B. Got this? What you can do, you can fold the circuit, or you can say the up and down will have same potentials. You can use either way. Great. Let's see a question then on this. Hmm. 3 into 3 grid. Each segment is capacitance C. Find CAB. Mm, 8 by 11 near, that is wrong. AC by 3, 3C by near. Another 30 seconds, I'll show you. You can use both axial symmetry and bisector symmetry. Let's see. You can clearly see here, this is a bisector symmetry. This is also the axial length symmetry. So you have both. So I can fold the circuit. I can, this node, look at this node. I can open this node also. Then what will happen? Your circuit here, I'll just redraw this. This is how it would look. This middle branch here will actually get removed like this. So they will join and these two will join. And if you look at all the capacitors, this guy will become 2C. 2C, because when you fold the circuit, this will become 2C. Yeah, I think everything will become 2C. This is how the circuit looks, everyone. Agreed? And once you get this, you can see this thing. This entire section will be 2C. 2C, 2C, 2C will be 2C by 3. So you can just read all this again for you. So we have a capacitor. And this whole bunch will be one capacitor, one capacitor, one capacitor. And becomes like this. So 2C, 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 and 2C. These are four capacitors here. That will become C by 2. And then these things will be 2C by 3, 2C by 3, C by 2. You can just add them up there in parallel. So that is 4C, 2 to 4, 7C by 6. 7C by 6, 2C, C will be C again. So 7C by 6 and 2C. I think 7C by 13. That's your answer. Someone got it. Kush got it. Check. That's how you use both the symmetries. Any doubts on this? Clear? Next one. How do I draw the star? There. This is A. This is B. Each segment is C. Yeah? That is symmetrical. I didn't draw properly. Find CAB. Hmm. 12 C by 11. Nah, that's not the answer. That star is it's a decent star, right? I didn't draw it well, but look at this. This is A. This is B. You can clearly see this is an actual symmetry. Left and right look same. So that means this point, the one I'm marking in green, and this point, both are same potential. Let's call it D. CM already using for capacitor. And next thing, look at these triangles. Huh? These two capacitors are in series, isn't it? That and this capacitor, so this entire triangle, if you see, that is in parallel. So you can replace this entire triangle here with 3C by 2. Similarly, this entire triangle can be replaced with 3C by 2. Similarly, I can do the same thing on the left hand side. So this is 3C by 2. This is 3C by 2. So if I just redraw the circuit here, if this is A, I have one capacitor C, then we get the triangle. The triangle is 3C by 2. Then I go down, I'll get one more triangle, 3C by 2. Then I get one more capacitor C, and then I reached B. The same thing will happen on the right hand side. C, 3C by 2, 3C by 2, and C. So actually, you can remove this capacitor in the middle because both the points of potentials are same. This guy can be removed. So if I actually open the star, this is how it looks. Is that making sense? This capacitor in the middle can be removed because left and right are same. So that thing has some potential there. And then you're done. How much is this? So this is 3C by 4, C by 2, 3 by 4, C by 2. And then double that, 6C by 7. Check. See whether I'm right or wrong. But got how to remove that? So if you have an actual symmetry, the left and right are identical, so potentials must be same. You can actually fold this also. When you fold this, that capacitor will look like this. You have a capacitor which is connected to same itself, isn't it? Like this. That is useless, isn't it? Potential same हो गया. So if you fold this, all capacitance will double. So same story. You can do that. All got this? Question is not over. Get this star now.
Sir, could you explain that last C?
What?
Sir, after the 2 3 C by 2, we get one last C. So, sir, where is it exactly?
ये नहीं उसी नहीं आएगा सही था ये C won't come. That I did a mistake. अभी क्या आएगा आंसर 3C by 4 C by 3 by 4 plus 1 that is 3 by 7. I still got the right answer. I forgot to do that, I guess. That last C won't come. I did a mistake. I did 2 mistakes. Still got the answer. Let's get this. Yeah, I guess. I don't think so. This is A, this is B. Yeah, if you see this is a symmetrical line. This is your bisector symmetry. A and B are on either sides of the terminal. This triangle here is 3C by 2. This triangle here, actually, I don't need to do the symmetry also, I guess. चाहिए नहीं. Without symmetry also, I can do this. This is also 3C by 2. 3C by 2. 3C by 2. Then I can remove this for the sake of removing. I can remove this thing. So we have A here, then we have one capacitor here. That is this capacitor. So we have 6 capacitors there. We have one capacitor, and this is connected to B. I can't make this one triangle because nothing is in series here. Then we got a capacitor. There. So I'll name the junctions for you. Let's call this C and let's call this D. So this is junction C and this is junction D. After this, we simply got 4 3C by 2s. Is this making sense? All the blue ones are still C only. Check. I will open this node. So that node got opened here. You can open the node along the symmetrical line. So that node can be opened up. It would have become like this. In the right side, I won't open the node because these things are all 4 are in series. So I'll just keep them as it is. What do you guys think? I think then we are done, I guess. So this 4 will be how much? 3C by 2 by 4. That will become 3C by 8. I'll just redraw this again. So CC, this will become C by 2 in the center. This is C. This is C by 2. So this is C by 2, and that is 3C by 8 by half plus 3 by 8. Multiply 4. That will be 3 by 16 by 4 plus 3, 7 by 8. That will be 3 by 14. 3C by 14 with a C again. So this entire chunk is 3C by 14. 3C by 14 and again C by 2. That is 7 and 14. So 3C by 28 by 10 by 14. So that is 3C by 20 plus parallel to C by 2, 10. 13C by 20. Right? Am I right? 3C by 2, 3C by... Anyone got this? This will be C by 2 and this will be 3C by 8. 3C by 8 into C by 2. Nay, shit, I won't parallel, na? Why am I doing that? That is 3C by 8 plus C by 2 directly. 4 and 8, so that is 7C by 8. This I'm having a problem nowadays. I'm doing this mistake into half by 7 by 8 plus half. 4 and 8. 7C by 11. 2 plus 7 by 2. Anyone got something? I'm not getting calculations. Check. 5C by 7, 9C by 8. 11 तो आ ही रहे मुझे. 10C by 7. I could be right only then. 7C by 22. 7C by 11 into 22. 7 by 22 plus half. 11. 18 by 22. 9C by 11. Check it out. I will leave it to you. Right or wrong. This is the last thing that I can get. I'm tired of solving. Right तो होना चाहिए. But got the process? Why are you guys? You're not solving, right? I'm solving and struggling. So you're looking at me and having fun. Idiots. इतना serious parallel solve करने के लिए. Get na? Someone should have got this thing. Something. 10C by 19. 10C by 7. I got 11. ठीक है. देख लो. Solve करके. You can do it from here. Got this? Let's see one more. You're getting this an infinite grid. Triangle under triangle, triangle inside triangle, and so on. This is another type of symmetry, an infinite triangular grid. All capacitance are C. Find CAB. Someone got 9/11. Okay. How do we do this? Can you see there's a symmetry? Let's see. So the first thing here, there is a symmetry, but there is a problem. You can't say this whole thing is X. You know why? Look at the whole circuit. There is A and B. This point is in air, isn't it? That point is in air. Now, if you look at this inside part, okay, chalo, I will call this A and B, but this point is not in air, no? It is touching here. You're getting it? So if you have ignored that and solved, you would have still luckily got the answer. But you need to understand, because there's an axial symmetry, and you can see all these junctions are exactly on that symmetry. So all these nodes can be opened up, isn't it? Now it will become, symmetrical. Now it looks like the whole circuit. So we have to use the bisector symmetry. There, now it won't touch it. Now it won't touch here. So now you can argue both are same. Previously, you can't say that. Both are not same initially. This point is not connected to anything. This point is touching. How are they same? So now we will say this whole section inside is identical to this thing. So you can replace this. There, this guy in the middle, that whole grid becomes X. This is C, this is C, this is C, C and C and C. So this whole equivalence is again equal to X, isn't it? That's what we did always in infinite grids. Any doubts on this? Pushkal, clear with this? Shashwat, Vihan? Vihan, clear? You can also try to ignore the upper point on the bisector. But boss, battery is between A and B, right? Why will you connect the battery wherever you want? Here, when you take the whole triangle, there is a battery, there is a battery. Here, there is nothing. For the inside one, when you want to replace, where will you give the battery? Here and here. The other one is not in air. It is connected to something else.
So we can't just open up that
Simple thing. Is this whole thing and inside same, yes or no? They're exactly same in every aspect.
No, so
No, then done. You can't do then. I have to remove that junction. Only then I can say they're equal in every aspect.
yes, sir.
So this guy will be C by 2 plus X. That and these two are in parallel. So C by 2 pi C plus X plus C by 2. This must be equal to X. I'll leave the quadratic to you. Solve. Okay, someone got 1 plus root 21, it seems. So you can check it out. Is this clear, everyone? The whole thing and the inside one are not equal. Because the whole thing, battery is here. So when you want to say the whole thing is looking exactly same, right? So this is looking like A, this is looking like B, great. But this is not looking like C. Clear? So this is one way to solve circuit symmetries. Like I said, there are 5 ways we have, 5 methods: series, parallel, Wheatstone, nodal analysis, and symmetries. So symmetries, again, we had cube symmetry, infinite grids, and then we have axial and bisector symmetry. There is one more thing called diagonal symmetry. As such, it is, it's not that powerful. It will give a problem on its own. It will be a part of some other problem. We will see that also later on. So the fifth technique is Kirchhoff's law. In that also you have two. One is the Kirchhoff's junction law. This is pretty nice, to solve circuits and all. In case none of the 4 techniques works, this is your last option. So what is Kirchhoff's junction law? Pretty straightforward. The charge entering a node must be equal to the charge leaving the node. It's like equation of continuity. The amount of water entering is what amount of water leaving. So there it was conservation of mass, here it is the conservation of charge. So the charge entering a node is equal to the charge leaving the node. So if someone tells you charge Q1 is entering, charge Q2 is entering, and charge Q3 is also entering, this is not possible because the net charge entering must be 0. So I can say Q1 plus Q23 is equal to 0. Making sense? Same way I can say charge leaving that entire node is also 0. So how do we use this? Listen to this thing. So let's say if you have 3 capacitors, C1, C2, and C3. Let's say this point is X, this point is V1, this point is V2, and this point is V3. So it's a junction law. So we generally use it at a junction. So let's say this side charge Q1 is going, let's say this side Q2 is going, and let's say Q3 is going. Now we know in reality it's not possible for the charge to go from a point. So the total charge Q1 plus Q2 plus Q3 must be 0. Next thing, from we know Q is equal to CV for capacitor. So what is V? Potential difference across the capacitor. Now listen carefully here. When you take Q1, it is going from X to V1. So you're assuming X is higher potential than V1, isn't it? Charge goes from higher to lower potential. This is our assumption. बाद में science will take care of it. So what is the charge का formula? C1 into X minus V1, because charge is going from X to V1, so X is greater than V1. Q2 will be capacitance into potential difference, again X minus V2. Q3 will be capacitance into X minus V3, equal to 0. Solve for X, you'll get the answer. So this is how you can find potential at a node. This is the main idea there. Let me show you an example how it works. But is the concept clear? The total charge coming out of a node is 0, or the total charge entering a node is 0. Charge has to be conserved. If it is not 0, means charge is getting stuck at the node. So where is the charge going exactly? You cannot have charge inside a conductor, remember? So let me show an example how it works, and then I'll give you one question. Let's say V, C, C, 2C, and 2V. Now, when you get a circuit, this is the first thing you need to think. Is this any series parallel is there? Can you see any series, any parallel? Okay. Can you see any Wheatstone bridge? No. Is there any nodal analysis we can use? Can you find any 2 points which have same potential kind of thing? Does it look? Not much. Can you see any symmetry? Nothing. Gaya, matlab, this is the thing. When you see a question, normally within 10-15 seconds, you get an idea, boss, nothing is working. Then you know, generally, I'll tell you one thing. If you see two batteries, generally, nothing works. You have to go to Kirchhoff's law. That is one thing you can think of. It's not a concept, but general observation. Whenever I saw two batteries, I know most of the time, none of the methods work. You have to directly go to Kirchhoff's law. So how do we solve? Listen carefully. Question is find charges on the capacitor. Let me show you one. Listen to the steps. Step one. Choose a point with zero potential. Since we are interested in potential difference, right, and not the exact potential, so better choose one point as zero. Makes your calculations easy. Choose a point with zero potential. You can take anything as zero. I generally take the points, with the negative terminal of the battery as zero potential. Step two, find the potential of the nodes. So after taking one point as zero, using that as a reference, try to find the potential of other nodes if you can. And if you can't find, then just put some variables x, y, z, and name the unknown nodes. And let's say if there are two variables, then we have to apply the junction law at two different nodes for two equations. If you have only one variable, then only one time if you apply it is sufficient. So based on how many variables you have, apply so many things. So look at this question. Step one, take a zero potential. Which point do you think is better? I will take the battery and negative terminal as zero. This will be zero. This will be zero. Agreed? The entire bottom wire will become zero. Second step, find the potential of other nodes. Now tell me, if there is a battery here, and if the negative terminal is zero, then the positive terminal is 2V. Similarly, if this is zero, this terminal is V. This terminal in the middle, I don't know. Any doubts on the naming part? Start from the bottom one is zero. Then I got two sides in the center. I don't know. There's a capacitor here. I don't know what is the relation between that and this. So I don't know. So this is the potential. Great. Next thing, assume charge is going this way. Q1, assume Q2, assume Q3. Why? You can take anything. It doesn't matter. Now we know the total charge Q1 plus Q2 plus Q3 is zero. Remember, charges are going from X. So you have assumed X is greater than everyone else here. So what is Q1? Capacitance into potential difference. X is greater than V, so X minus V. Q2 is 2C, charge is going from X to V, so X minus 2V. Q3 is capacitance into X minus 0. Is that making sense, everyone? Capacitance into potential difference is charge. C gets cancelled off. We get X minus V plus 2X minus 4V plus X is equal to 0. From here, we get X is equal to 5V by 4. Once you got X ka value, you're done. You can find the charges. What is Q1? C into X minus V. CV by 4. What is Q2? 2C into X minus 2V. 5V by 4 minus 2V minus 3V by 4 minus 3CV by 2. There, as expected, someone has to be negative. Q3 will be C into X, so 5CV by 4. So the Q2 is actually not going to the right side. Q2 is actually coming in towards X, isn't it? So you don't worry about the distribution. The science will take care of it. This is how you can find charges on each thing. Have a look at the steps. All clear with this? Let's see if you have problems. That is our best way to get the hang of it. But the process is straightforward. The 3 steps. Any doubts on the steps? Adi, clear with this? Let's see. V, 2V, 3V, C, 2C, 3C. Find charges on the capacitor. You can take any variables you want, but end of the day, you'll always get the same answer. Try, I'll give you another minute, then I'll show you. Puraj, if you add all three, should get 0. Are you getting it? Isn't that the whole basis? Let's see. Step 1, find a point with zero potential. Generally, the best point is always a negative terminal of a battery. Makes your life easy. If you take that as 0, this guy becomes V, this guy becomes 2V, and this guy becomes 3V, isn't it? That is the best point to start. So finding a good point is also important. Actually, you could have chosen anything, but that would be the best point. And this is X. You got three variables. So let this guy be Q1, let this guy be Q2, let this guy be Q3. I always prefer to take the charge is always going away from one point or coming towards one point. Instead of taking Q1, Q2, Q3 in different directions, keep it simple. Science will take care of it. So Q1 plus Q2 plus Q3 is 0. So you're assuming X is greater than everyone. So for the capacitor C1, C will be X minus V. For Q2, it is 2C minus X minus 2V. 3C into X minus 3V equal to 0. C gets cancelled. We get X minus V plus 2X minus 4V plus 3X minus 9V. We get 6X is equal to 14V and we get X is equal to 7V by 3. That point of potential is 7V by 3. Yeah, and then you're done. So Q1 will be 7V by 3 into C, 4CV by 3. Q2 will be 3 to 6 CV by 2 CV by 3. Automatically Q3 must be minus 2 CV. Did anyone get this? Yeah, Saish got it. So if I just draw the circuit again, just to show you how the distributions are. So the thing is, the one who is giving the charge is actually the 3-volt battery. The 3-volt battery is pushing the charge in the remaining two batteries. So the Q3 is actually flowing from here, which is 2 CV. It's going in reverse. So this guy is giving 2 CV. And then here it is splitting 4 CV by 3 and 2 CV by 3. So be careful. This is the positive plate, this is the positive plate, and this is the positive plate, isn't it? Those are the positive plates, the one which I marked in the red. So whichever plate the charge touches, that is the positive plate. The other plate becomes negatively charged induced. Is this clear, everyone? Anyone not convinced with this? Great. Let's see one more like this. Find C equivalent. This is an unbalanced Wheatstone bridge. How do we start this? Listen, I'll give you a little idea there and you go ahead. So in this circuit, I'll start with the 0. This will be V. This is 0. This is V. This is X. And this is Y, isn't it? Those two nodes are completely different. X and Y have no relation to each other. This is 3C, 2C, C, C. I don't know what the hell are those 2 points. So I don't know. So X and Y, simple. Then let's say charge this is Q1, this is Q2, this is Q3. Remember, these things really don't have much of a significance. They're just going in. Let this be Q4, let this be Q5, and let this be Q6. Actually, Q3, Q5 are equal and opposite. Doesn't matter. Now listen to this thing. This is the important thing. If you look at this branch, so that means here the charge is going Q1, and that means here the charge is going Q4. That means from the battery, you're getting a charge of Q1 plus Q4. Do you agree with that statement? From this diagram, we know charge Q1, Q4 is coming from there. That means we know C equivalent is nothing but the charge flowing through the battery by the voltage of the battery. So indirectly, I'm asking you, find Q1 by Q4 by V, isn't it? If I know how much charge is going through the battery and divide by potential, I should get C equivalent. Now I have just taken random Q1, Q2, Q3, Q4, Q5, Q6. From this distribution, I need to find Q1 and Q4. There, that's your job. Now find X and Y, find Q1, Q4, and then divide by V, and you will get your capacitance. That's why we have to find C equivalent if they ask you. In this, there are 4 nodes. In that X and Y, I don't know what are those. Try, I'll give 2 minutes now. This is the starting part. Meaning if you got this, then it's just a matter of solving. No? नहीं रे थोड़ा सा I don't think that's an answer. 3C, 2C, 3 नहीं हो सकता है actually I don't remember the answer but 27 ठीक है who knows. Let's see, we have one answer 31 by 27. Yeah, you won't get a good answer. इतना तो है, you'll get some numbers like this only. Anyone else? Apply junction law for X and Y. First find X and Y. Then find Q1, Q4, and then substitute by V. Solve, Pushkal, solve. X is 4 by 11, Y is 5 by 11. I don't know. Let's see for X. Check your potentials. Q1 plus Q2 plus Q3 is 0. Charge is coming towards X. Huh? So I took X as a smaller potential. So that is C into V minus X. It won't matter actually, but okay. Then 2C into 0 minus X. Then C into Y minus X. Check your equation. Because the charge is coming to X, the other 3 guys are higher potential. C will cancel. V minus X minus 2X plus Y minus X is equal to 0. We get 5X minus Y is equal to V. That's your first equation. Node Y, Q4, Q5, and Q6 is 0. Hmm. 3cb minus y, cx minus y, c0 minus y. 3v minus 3y plus x minus y is 0. Hmm. This is 5y minus x is equal to 3v. Hmm.
सर वो इक्वेशन वन में 4x होगा ना?
4x होगा वो. Then substitute here. This will be 5. Y का place में you have 4x minus v minus x is equal to 3v. This is 19x. And this is minus तो 8v. X is equal to 8v by 19. 5 fourths 20. 20 minus x is 19. Anyone got this? 8v by 19? Okay, we got. Then y कितना था? Y will be substitute करना पड़ेगा वापस. Anyone got y का value? I'm too lazy to solve. 13v by 19 it seems. ये आना चाहिए. If you got this, I think the next part. If this is gone, तो gone. Check. Solve. At least solve the equations. I'm teaching you now. At least you guys solve and give me numbers. Lazy people. Not even solving the equations. Hi, Shana.
Sir, in these we take only the positive values, no? The ones which are greater.
Which one? कहाँ पे? X and Y बोल रहे हो?
Like in V minus X, V is greater.
No, see, think of like this. Where is the charge coming from? Q1 is coming from V to X, no?
So then in one equation we wrote Y minus X, and in the other we wrote X.
Which one? Which part? Node X or node Y? Which one are you talking about?
In node X we wrote
Node X
Y minus
में
X.
look at Q3. Q3 is coming from where to where?
Y to X.
So Y is higher than X, na?
Oh, and in
Look,
node Y we wrote X minus Y.
node Y में charge Q5 is coming from X to Y, so X minus Y.
Oh,
Getting technically Q3, Q5 are opposite, but we really not interested. Just for the convention, I took some variable. इतना देखो यहाँ पे देखो ना एक Q. See for Q2 what did I do? I wrote 0 minus X. So simple. Charge flows from higher to lower potential. So if you have taken Q2 that way, I am assuming 0 is greater than X. Assumption. Sign will take care of it. All got this? अभी Q1, Q2 कितना आया था? So ये हो गया. You need to find Q1. So Q1 is C into V minus X. X is 8V by 19. How much is that? 1 minus 8 by 19. 9CV by 19. Nah. Today something is bad. I can't solve stuff. 11CV by 19. Q2 is how much? Q2, Q4 चाहिए ना? Q4 I need this guy. 3C into V minus Y. Y is how much? 13V by 19. 18CV by 19. Wow. Then Q1 plus Q4 by V C equivalent gets cancelled. 29C by 19. That's your answer. Devansh also got it. Yeah. That's the capacitance, everyone. Yeah, that looks right. Got the process? So this is how you solve an unbalanced Wheatstone bridge. And this is the headache. It doesn't look great. All clear with this? Let's see one more. Now in this, if they want to ask you something easy, they will do something like this. This is an easier version. C, 2C, 2C, and C. I wanted to give you the tougher one first. So if you see, there is a symmetry actually here. This is called a diagonal symmetry. This is 2C, this is 2C. This is C, this is C. So what is the catch of a diagonal symmetry? Listen, if Q charge is going, Q charge comes out, right? If that looks confusing, na, sab log aisa socho. If Q charge is coming, SU minus Q is going inside. Can I say the same thing? Same thing, na? Q is going away or minus Q is coming in are the same. If I say this is Q1, can I say this is minus Q1? Whatever happens here, same thing should happen there. So if this guy is Q minus Q1, then this guy is minus of Q minus Q1. You get in the symmetry there? Whatever charge flows here, same thing will flow here. So simple thing, that means the potential difference across this must be equal to potential difference across this. Potential difference. Similarly, because charge is same, na? Charge is same, capacitance is same, so potential difference is same. So whatever happens here, same thing will happen here. Whatever happens here, same thing will happen here. So this is called a diagonal symmetry. As such, it's really not a powerful one. It can't eliminate the whole thing, but yeah, it will make, it will decrease one equation generally. So saves you little time. So try how to solve this. Then I'll show you how to use diagonal symmetry in this. You could just normally use brute force X and Y and finish it off. But the diagonal symmetry concept will make you get the answer in very less equations. That's it. C by 920. So look at that argument here. Huh? Since this, they look identical. This is a diagonal symmetry. So the meaning of this is if charge Q flows here, and if this is small q, Q goes out, this charge also will be small q. Okay. That means if this is Q, this is Q, this is Q minus Q, this will be Q minus Q. If this is V, if this is X, this is 0, and this is Y, look at this. So I can write Q is equal to 2C into V minus Y. Q is also equal to this guy, C into, sorry, this is also 2C. 2C into X minus 0. From here, you will get V minus Y is equal to X. Or you can say Y is equal to V minus X. The potential difference is same, no? So whenever you get a diagonal symmetry, remember this thing, it will help you. This is 0, this is V. If you say this is X, what is the potential difference here? V minus x. So this also must be V minus x, but that is already 0. So this is V minus x. Are you getting it? So this potential difference is V minus x. This potential difference is V minus x. This potential difference is x. This potential difference is x. Can you see that? Potential difference same होना चाहिए. So the advantage of this thing now, y will get eliminated. You will get only one variable. So you still have to use junction law. So if you apply the junction law here, Q1, Q2, and Q3. Q1 plus Q2 plus Q3 is 0. Then, yeah, you will get it. How much is this? C into V minus x plus 2C into 0 minus x plus C into V minus x is equal to 0. Two V is equal to 5x. X is equal to 2V by 5. So from there you can find the charges. So if that is Q2, this also will be Q2. So C equivalent will be Q1 plus Q2 by V. You will get the answer from there. C नहीं आएगा रे, इतना अच्छा आंसर नहीं आएगा. Clear with this? You can solve this. There. So if at all they ask you this unbalanced Wettron bridge, in that they give you diagonal symmetry, you can directly write this is x and V minus x. That's it. There's nothing there. This will become especially useful, when you have multiple grids like this. Later on, you will see resistors में. They'll give like this. So this thing is actually diagonal symmetry. So if this is V, right, and if you say this is 0, if you say this is x, this will be V minus x. You're getting? This and this are identical. ये भी diagonal symmetry था. Anything from the back. If this is y, then this is V minus y. This and this will be identical. So it can be used like that. So it will make your life easy. But like I said, diagonal symmetry is not really that powerful. It will solve the whole question. It will reduce the variables and solve करना पड़ेगा. So something of that sort. So I'll just leave this example here. Same thing. If you call this z, so this will be V minus z. हो गया ना? You got only like 3 variables x, y, z. So 3 nodes, apply and solve. So this is also a diagonal symmetry. Clear with this? So symmetries में that is one more thing. Next thing, Kirchhoff's loop law. Now this, I really don't prefer this for solving circuits as such. If you just want C equivalent or voltages, use junction law. But this is very useful, when you're dealing with multiple elements, capacitor, battery, resistor, everything is mixed up. Then this thing really works well. Junction law, then it becomes sometimes very cumbersome then. So what is Kirchhoff's loop law? This is similar to energy conservation. The sum of potential differences across the elements in a closed loop is 0. Kind of makes sense. What it says, you start from one point, you go round, and come back to the same point. What is the potential difference? 0. Then a closed loop, the potential difference has to be 0. Energy conservation. A better variation of this is this. If you want potential difference between 2 points, not a complete loop. So potential difference between 2 points is sum of potential difference across the elements. In any path, let's say if you want to go from A to B and there are like 10 paths, you take any path and you add all the potential difference between them, the difference has to be same. Obviously, because A and B are still the same. So it doesn't depend on the path between the points. Do you guys remember electric potential is what? Conservative, right? Electric field is conservative. So potential is conservative thing. So potential difference between 2 points or energy between 2 points won't depend on which path you take. Now, the next important thing is the sign convention. So when we use this Kirchhoff's loop law, we need to be careful with the sign convention. Idea is pretty simple. In some books, they might use the opposite of this. So you see which one you're more comfortable, but we will stick to this convention. We will use a very simple convention. When we go from higher to lower potential, potential decreases. Kind of makes sense. When we go from higher to lower, potential drops. So this is the convention we follow. If you have a battery V, negative terminal, positive terminal. If you go from negative to positive terminal, that is left to right in the battery like this, the potential increases. So right plus V. If you go from right to left here, you're going from plus to negative. So potential will decrease. So drop is minus V. Make sense? Straightforward. You go through the battery from minus to plus, potential increases. You go from plus to minus, potential decreases. You take a capacitor and let's say this plate is positive plate and this plate is negative plate. If you go from positive to negative plate, potential will decrease by Q by C, so minus. If you go from negative to positive plate, potential will increase, plus Q by C. Simple convention. Have a look at this. Now, how do we solve the circuit? First thing, if there's more than one battery, it doesn't matter. Assume, take any one battery and assume that guy is giving charge to everyone. Science will take care of it. Second thing, using junction law, distribute these charges. Third, now after distributing, see how many variables you have created. So let's say you created two variables, Q1, Q2, and something like that. Then apply Kirchhoff's law. So if there are two variables, applied two times, such that so when you're applying the law, make sure all elements are covered once. Let's say there is one battery, two capacitors, and two resistors, or whatever, like three capacitors and two batteries. Make sure when you're going through the loop, right, you're covering. I'll show you. Matlab, it's not necessary you cover all of them in one loop. Make sure if there are three equations, the element comes at least in one of them, such that all elements are covered at least once. If you want to find C equivalent, sometimes I'll just give you a circuit without any batteries and ask you for C equivalent. Then assume a battery giving charge Q and find Q by V ka ratio. Let me show an example. That's the fastest way to do this. But look at the steps. So I will take the same example which I did for junction law so that we can match the answer. Two V, C, and 2C. Step 1, assume charge from any one battery. I'll assume charge Q is from this battery. So charge Q is going, so this is the positive plate. So Q will go forward, distribute the charge, let this be small q. That is the positive plate, so Q will come out. Then the balance charge will go here, Q minus Q, that is a positive plate. Q minus Q will go from here, Q minus Q will go from here, and Q will come back to the battery. This is the important thing. If you send Q from the battery, Q has to come back to the battery. Is the charge distribution clear? You can take any variables you want. I have chosen like this. Step 2, we distributed the charge. Take this loop and I'll take this loop. I will take these two loops. You could have taken the whole loop also. I'm just taking the two loops. Let's start with the right loop. So listen carefully, everyone. The sign convention, there's nothing there. You just have to be careful with the signs. You can start from anywhere. It doesn't make a difference. So I'll just start from the battery and I'm going anti-clockwise. So I'm starting from this point here anti-clockwise. First, I'm going through the battery. I'm going from where to where? Negative terminal to positive terminal of a battery. The potential will increase, plus 2V. Battery is over. Now I'm going through the capacitor 2C. I'm going from positive plate to negative plate. So potential must drop. How much? Charge by capacitance. Then I'm going to the middle capacitor. Again, I'm going from positive to negative, minus Q by 2C, minus Q by C equal to 0. Got the equation? If you came back to the same point, total is 0. So this guy will be 2CV is equal to Q by 2 plus Q. This is your equation 1. Now do the same thing for the left loop. It doesn't matter where you start. If you start somewhere else, these three terms will come the same terms. They'll just get jumbled. I'll start again. I'll start from this point here. I'm going anti-clockwise again. I'm going through the positive plate, Q minus Q. So minus Q minus Q by C. Then I'm going opposite to the battery. I'm going from plus to negative of the battery. So potential drops minus V. Then I'm going here, look at this middle plate. I'm going from negative to positive plate, plus Q by C equal to 0. This guy will be CV is equal to minus Q plus 2Q. Take that small q, substitute here, CV is equal to minus Q plus 2 times 2 CV minus Q by 2. This would be minus 3 CV and this would be minus 2Q. Q is equal to 3 CV by 2. And if you look at this example when we did, yeah, how much we got there? We got the same chassis, 3 CV by 2 Q2. I got minus because here I assumed it is like this, so reverse of it. Clear this? I don't like this. The reason you can clearly see, you just need to goof up one sign and the whole thing will go for a toss. One sign convention, one term, something here, there, and the whole thing will go for a toss. So if you just want to find circuits or charges, junction law is the best. This has its own uses, but yeah. Clear with this? Now let me give you one more equation. You guys find the equations so that we need to still get used to the equations though. So that we all get the same equations. I will give the chart distributions and the paths. So you just find the equations. So this is V, this is C, this is 2C, this is 3C. Let's say this is 4C and this is 5C. So let the charge Q come from the battery. Let this charge be Q1. That means the balance will go here, Q minus Q1. Let this be Q2. That means the balance will go here, Q minus Q1 minus Q2. Then this will be Q1 plus Q2. Then Q comes out again. This is a distribution. So positive plate, positive plate. This is the positive plate, and positive plate. So I want you to use the right loop, the left loop, and I want one loop going through the battery, going through C and 2C and back. There are three variables, capital Q, Q1 and Q2. So I need to get three loops. Everyone got the loops which I'm asking? Battery, C and 2C back to the battery. So get me the equations. I just want the equations with signs and everything. Get it? I'll give you a minute. If you got the equation, then you know how to write. Get them. Get the equations. I'll get some water and come. Done? Let's see. First, the left loop. Check whether you got the answers right. Start from anywhere. I'll start from here. If you start somewhere else, you'll get the terms will be same. They'll be just jumbled. Starting here, and I'm going clockwise. Minus Q1 by C. I'm going from negative to positive plate, so that is Q2 by 5C, and then plus Q minus Q1 by 3C. See if it went wrong. Check it out. Ask me if you're confused. The right loop, I'll start at the top. That's why I gave 1, 2, 3, 5C. So you can, if you're confused, you will see which capacitor you got confused. 2C, then plus Q minus Q1 minus Q2 by 4C minus Q2 by 5C is 0. The big loop is the easier one. V minus Q1 by C minus Q1 plus Q2 by 2C equal to 0. All got? Vihan.
Sir, Q2 is basically, we can see minus Q2 is coming down from negative to positive for the middle 5
What you're talking? ठीक
So
है,
for the
so
5. So then, sir, minus Q2 is going in a positive direction. So shouldn't it be minus Q2 by 5C?
which loop are you talking about?
So that capacitor, the 5C
Which loop
capacitor,
are you talking about?
left one, left.
Left loop. Left loop में you're going from here to here. ठीक है. You are going from here. This plate is positive or negative plate.
Negative.
So if you're going from negative to positive plate, potential increase or decrease.
Okay, so it doesn't matter which direction is written.
What direction is written? Array God, how do you decide this was a negative plate? Because of this direction only, na, this became positive, so that became negative.
Okay.
And then the way you decided that was a negative plate, how did you decide it was a negative plate? Because you know the bottom charge is coming. So this was plus Q2 and that was minus Q2, isn't it?
Got it.
So you decided based on the flow only. Na? If I had given Q2 from the top, then I would have said this is the positive plate, isn't it?
Yes.
So the flow decides which is the positive plate. So yeah, you could have asked me, sir, how do you know Q2 is coming from? I could have taken Q2 down also. I could have taken it. The science would have taken care of it. But yeah, got it. And remember, when you say Q is equal to Cv, what is Q? Q is the charge on the positive plate ka inner surface. So keep it simple. All clear with this? Now let's see where this thing will actually shine. There, we got a circuit like this. All our capacitors, all capacitors are C. Now let's say 20 microfarad. Find the charge on that C. This capacitor mein, what is the charge? We have two batteries and remaining all are capacitors. For the big loop, actually you could have taken any path. You could have gone like this in the middle also. You could have taken anything. I just took one thing, that's it. You can't do this thing. Listen, everyone. Isme na, you took this one, you can't take this one again. Because if you take that, you didn't even consider battery even once, isn't it? That is one. Second thing, this loop plus this loop is big loop only. So you don't get any unique equation. Kya aana this mein? These kind of things, when you see they look scary and all. What do you guys think? I'll tell you the idea. See, find a path where in that particular path, this is the only capacitor and everyone else is a battery. What would happen in that case? Imagine if this was the only capacitor and if everything else was battery. When you apply Kirchhoff's law, you will get battery, 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 some battery minus Q by C equal to 0, isn't it? The problem is if you touch one more capacitor like this, then you have to write minus Q2 by C. And I don't know what is Q1, Q2. So somehow, if you can find a path where this is the only capacitor in that particular path, then I can find the charge on the path, charge on the capacitor. Is that logic making sense? So can you find a path where this is the only capacitor? You can have any number of batteries, but don't touch the second capacitor. This is like the Times of India में आता है ना maze का puzzle. Find the cheese type. दोनों लेने की जरूरत नहीं है. Why should you take both of them? I just said find a path where there is only one capacitor and any number of batteries. Do you guys find? So there's an easy one. So it's like this, go like this, like this, like this. There. So if you write this thing, so 20 volt, there is no capacitor, no battery, nothing, nothing. Minus Q by C is equal to 0. So Q is equal to 20 into capacitance is 20 microfarad. 400 microcoulombs. Make sense? Aditya, clear? So you'll find these kind of questions also, meaning I'll show you one more, which will come in current electricity. We will solve then. For now, let's just find the path. This is still innocent. You'll actually find huge mazes. Can you find a path where this is the only resistor? Will you? So once you know you have to find a path, question is easy. But the first time when you see the circuit, you feel like, what the hell is this? Series, parallel, Wheatstone, कुछ नहीं लगेगा. मतलब Kirchhoff's law also will get scared to apply. There, as a kid, if you had solved those puzzles, my maze ka things, finally it is of some use. So go like this, go up, come down, go down. Then you can go right or left. You will complete the path. You can go left also, you would reach. Got the path? So if you see, I went through multiple batteries, but I didn't touch a second resistor. I can find the current in that resistor. So we will see this question again in current electricity. So if you see these things, right, Kirchhoff's law is very useful. Junction law, you will die. Got this? So this is one type of questions there. The next variety is this. Suppose if you have a capacitor, we have a capacitor. And let's say we have a switch. This is C, this is 2C. Let's say this charge is plus Q and this charge is minus Q and this is empty. Simple one, find the charges and the heat produced when switch is closed. These are one important type of questions that comes a lot in mains. They took a capacitor with charge, another capacitor is empty, they connected, what is the charge and all. Think for a minute or two, how will you do? I will show you a process how to do these things also. This is will be an easy one. What if there are 2-3 capacitors and battery and also? We will have a process. How do you approach this? Hmm. Listen, I'll show you the steps. Same story, yeah? What we did in Kirchhoff's law, we will do the same thing. So instead of a battery, we will assume like this. So step one, assume any capacitor, is giving a charge. Assume charge Q flows from a capacitor. Step two, find the new charge distribution and apply Kirchhoff's law. I would prefer this method because it just looks like, your battery ka distribution. And second thing, sometimes they'll ask you how much charge flowed through the switch. This becomes easy to handle. You can also use charge conservation and figure it out, but when there are more capacitors and batteries, this will help you a lot. Always have a process. Don't mug up the problems, but remember the process. Even something changes, you'll know where to adjust. So this is what we'll start with. Let Q charge go from here, small q. So if Q charge goes from there, Q charge goes here, and Q charge has to come back, basically. That's the story. So if Q charge has flown from here, can you tell me how much charge will remain on the plate? Q minus Q. Getting it? I'm marking the plates in red. These are the positive plates. The other plate is automatically negative. So if this Q charge is flowing and coming here, then this plate will become plus Q. Automatically, the other plate is negative. This Q charge will continue to flow, will reach the other plate. Is the distribution clear, everyone? So that Q will has to go and come back again, just like a battery. Is that making sense? And logically, socho na. इसमें पहले minus Q था. When this plus Q comes, you will get, see, now they are equal and opposite. The plus Q has to come back to the other plate. All got the distribution. Now apply the Kirchhoff's loop law. I'm going in the loop. So start from anywhere. So apply Kirchhoff's loop law. I'll go with the charge. So I'm starting here, see. I'm going from where to where? The blue plate is negative plate, red is the positive plate. I'm going from negative to positive, so potential will increase. Q minus Q by C. That's it. Understand why it will increase, because you're going from lower to higher. Then I'm going from positive to negative plate, potential will decrease, so minus Q by 2. See, you came back to the same point as 0. This will be Q is equal to 3Q by 2. So therefore, the charge distributed is 2Q by 3. That means the final charges are Q by 3 minus Q by 3, 2Q by 3, and minus 2Q by 3. What is the heat produced? Heat produced is nothing but U initial plus work done by batteries. Here there are no batteries minus U final. So find U final, U initial, finish it off. Initially the energy was Q square by 2C. Finally it was Q by 3 whole square by 2C minus 2Q by 3 whole square by 2 times 2C. So all that you'll get the heat produced. Are the steps clear, everyone? How did it distribute the charge? I applied a Kirchhoff's law and the heat produced. All clear? Vihan? Next one. Now you guys try. This is the main one. Every time you won't be lucky to get only 2 capacitors. Let's say this is 2C, C, and this is C. Let's say this is 3CV. This is minus 3CV. Let's say this thing is minus 2CV, and this is plus 2CV, and this is empty. Find final charge distributions. They can ask you find the final charges. Yeah, there's no battery. I can ask you final charges and the final potential difference also. That is charge by potential anyways. Get this? You guys took charge Q from where? The 3CV wala. So I'll assume Q is flowing from here. So Q goes here and Q comes here. So this plate mein the remaining charge will be 3CV minus Q. This plate mein charge will be Q. This plate mein initially you had 2CV, so this will be 2CV plus Q. Getting the charge distribution. So whichever plate the charge touches is the positive plate. If it is negative plate, let the signs take care of it. You don't get into that headache. Then apply Kirchhoff's loop law. Start from anywhere. I'll just start from this capacitor here. You're going from negative to positive plate. So plus 3CV minus Q by C. Then you're going through this minus Q by C minus 2CV plus Q by 2C. This will be 3CV minus Q minus Q minus CV minus Q by 2. 2CV is equal to 5Q by 2. Q is 4CV by 5. Got this? Now, you might have taken a charge from some other plate. It doesn't matter. The final answer should match. So the final charges would be, how much is this? 4, 3, 12 minus 4. So this guy is 8CV by 5. 15 minus 4, no? 11CV by 5. This is 4CV by 5. 14CV by 5. Make sense? All got this? The right plates are the positive plates. So that's the charge distribution. Easy? Just treat it like a battery. If you have a capacitor with charge and there's an empty capacitor, send the charge Q through this and finish it off. Any doubts on this? Let's do something even better. What if you have a capacitor, and we have a battery also now with a switch. So this battery is V. Let's say this is 2C, this is V. Sorry, that is C. This thing has a charge minus 3CV and this thing has charge plus 3CV and this is empty. So can I say these two capacitors are in series? Go back to the capacitor series ka definition. They should have same charge. Just because they're side by side doesn't mean they're in series. Are you getting it? Be careful with that. Just because you're side by side doesn't mean you're in series. They are not in series. Find the charges and the heat produced when switch is closed. This would be a good one. So in case of a battery, let charge Q flow from a battery only. You're getting it? If there is no battery, then assume one capacitor. Q is coming off a capacitor. But if you have a battery, let battery only give the charge. Finish off. Last one for the day. I'll help you with the charge distribution. Let this be Q. Q. Q and Q comes back. Meaning this guy, again, I can assume any plate as positive, my wish. So this guy will be Q minus 3 CV. You're getting it? So the science will take care of it. And this guy is Q. Make sense? That plate initially had minus 3 CV. I gave small q. So the charge has become Q minus 3 CV. And that charge Q continued to flow. The empty capacitor got a Q and Q came back. Any doubts on this? And be careful, the two capacitors are not in series. So that is one important thing you need to know. 2C and C are not in series because they don't have same charge. Most common mistake. Just because you see side them, beside side by side, you think they're in series. Yeah, then apply Kirchhoff's loop law. I'll go through the battery. V minus Q minus 3CV by 2C minus Q by C is 0. This is CV minus Q by 2 plus 3V. 3CV by 2 minus Q is 0. This is 5CV by 2 is 3CV by 2. 3Q by 2. Q is equal to 5CV by 3. Am I right? Got the same distribution? Now after got the distribution, now look at the capacitors, the final charges. And now you tell me you still think they're in series. So what is the new charge now? 5 CV by 3 minus 3 CV. That is 9 minus 4 minus 4 CV by 3. This plate is 4 CV by 3. This plate is minus 4 CV by 3. This plate is 5 CV by 3. This plate is minus 3 by 3. Do they look like series? Do they look like series? They will never be in series, ever. Problem is, if you look at this system as this thing, the plus 3 CV charge is stuck there, isn't it? On those two plates, 3 CV charge is always stuck. So kuch bhi karo, you can't remove that charge from there. The two capacitors can never be in series. I think, yeah, you're done. So what is the heat produced? Initial energy plus work done by battery. Now battery did work. Minus U final. How much did it do? So here 5 CV by 3 went here. So work done by battery is charge coming out of the battery, 5 CV by 3 into V. 5 CV square by 3. That's your work done by the battery. Initial energy, there's only one capacitor with energy there. So that is 3 CV whole square by 2 times 2C. Work done by battery is 5 CV square by 3 minus the final energy. Yeah, this is messed up. 4 CV by 3 whole square by 2 times 2C plus 5 CV by 3 whole square by 2C. Solve that, you'll get an answer. Other steps clear, everyone? There, this is a case where you had a capacitor with some charge and you have an empty capacitor. You won't have this problem in both empty capacitors. Because the moment you give charge Q, Q will come here, Q will come here. Now they'll be always in series. So if one capacitor is already charged, there is a high chance both will not be in series. So always be careful. The condition for series is same charge and same branch. Just because they're side by side in same branch, don't blindly assume they're in series. Clear with that? So we will see something like that again in the next class. We will see one more paragraph type question. And then we'll go ahead with dielectrics labs and all that stuff. So let's see, mostly next class, we should be able to wrap up most of it. It might spill over a little then, but next week we are starting with current electricity. So go through the notes. We have done almost like 26 problems. We did some pretty good models and, circuits and all that stuff. So do make sure to go through that. Okay, with that, we'll wrap up for the day. We'll catch up again on Friday as usual. And do remember, there's a test online on Thursday. So make sure to give it. So any doubts, anything you can stay back and ask, or else you're free to leave. So take